right, how's it going, everybody? So it's Wednesday, which means we're going to be working on the compiler. Hey, Yo Beats, how's it going? So if you haven't been following along with the compiler work so far, you can gain more context if you go back to previous episodes. In particular, the first episode is going to talk a lot about exactly what it is that I'm working on and like what the motivation behind it is, and kind of what our overall plan is from a high level view. Hey Andre, how's it going? Mr. Milkman, good to see you here. So let's see. What I've got here is basically the current branch, and I can pull up let me pull up like the CL in case anyone wants to go and look at it directly. They can do that. Okay, so this is essentially what we're starting from right now is this CL. So feel free to take a look at that. And let's go ahead and get started. I've done a little bit of work since we last kind of worked on the compiler here, and let me go through some of that work a little bit. Basically, we kind of had an overarching decision to make, which was a lot of the early work that we did was moving moving all of the analysis of the stable inference onto the front end of the compiler. And the primary motivation to do that was to keep the front end where sort of all the analysis happens, which would allow us to use some of that analysis from an IDE if we wanted. So we could expose to the user like some of the inference information that we're gathering here. Ultimately, I ended up deciding against that and moving away from it, because in the IR backend, which is where most of the compose generation happens, we need to use this information, and it didn't seem like there was a sort of desirable way to transmit that information from the front end to the back end. Basically, we could have attached the metadata onto descriptors, but JetBrains is actively trying to move away from descriptors being accessible in the backend, so we don't really want to do that. And so what I decided to do instead is to move all of the inference actually onto the backend, the IR backend. And so that's what we're doing now. So you can see I have a lot of these like the stability of functions defined here in the backend. This is the abstract compose lowering class. And this is where I'm now sort of doing the inference to check if individual, classes or types or whatever are able to be considered stable. And I think that that's gonna just work out better for us. The other thing that we needed to figure out was how to, when we essentially save the stability of a given type on a class, we need to pass that, like we need to store that in the bytecode somehow, and we're going to store it as like a static final int. But if we're adding an int to a class, we need to be able to like check to see if that int is there when we're in another compilation unit. And there wasn't really super easy way to do that, but now I have this. Hold on, use descriptor. So there's a Kotlin has this descriptor serializer plugin, and hey SkyColor, how's it going? And so this is what we're gonna end up using, and this is basically a plugin into like the serialization phase of Kotlin. So basically, when you compile Kotlin, it'll generate like a bunch of JVM bytecode, and that JVM bytecode is like kind of what the module is, but then it'll also generate some metadata, and in the eyes of like the front end of other modules, that metadata is sort of like the face of that bytecode, and so it kind of represents like what the Kotlin source looks like versus what the bytecode looks like, which could be quite different. And so we want to essentially add on here the information that we added this int onto this class, and this will mean that when it gets deserialized from another module, that int will show up there. So uh-oh, did I lose some of this work? I think I might have. No, it's here. Oh, I thought it was. Okay, here it is. Hey Marcel, how's it going? Yeah, SkyColor, I saw that tweet. I haven't yet responded to it. Sorry about that. There's definitely a better way. I'll try to get to that later today. The last like 48 hours have been kind of hectic for me. Sorry. Hey Nico, I'm doing good today. Okay, so this is this like stability field serializer that I started working on, and I mean basically all I'm doing right now is just trying to add this property to basically every class that comes in, and then just sort of like see if that's like readable from other modules and stuff like that. And that's kind of where I ended. So we're gonna kind of start off from there and see how things are going. So I've got this like cross module test. We've basically, it's sometimes hard to test things that happen in separate modules in the compiler because it's really important to do that because you know, things end up going down very different pathways if something is pulled from a separate module versus the current module or something like that. So we've got this way to test that, and so what I'm doing is inside one module, I'm just creating this empty class basically, which we're gonna end up generating a stable field on this, and then in this module we just have some composable functions which ends up passing one of these foos in as a parameter. And so because we're passing it in, we're going to end up checking the stability of that type. And so this is a sort of, you know, kind of integration test of this stability thing going on. So what I want to do is just try debugging this, and inside of this like main transformer, which we call the composable function body transformer. We call this, which builds the changed parameters for the call. And actually, I'm not really sure I even care about that. So what we want is, oh, I've got a bunch of stuff still in here. All right, let's make sure all this compiles. Taking a while to to collect those imports. Okay, so I think this will work. Let's oh, the build's still running. Let's stop that build and we'll just start it again. And then what I want, so this is where we're getting the IR class. We're determining the stability of a class. And so this is where I want to set a breakpoint, because this is where foo will show up. And so then we want to look and see if there's this like static declaration on foo or not. So let's run that again. By the way, I just went through like a bunch of stuff. I didn't necessarily take a lot of time to explain it. So let me know if there's something that didn't make sense to you. I'll try and explain it better. And I just cherry picked this change down. So this initial compile is gonna take a little while. I wonder, it looks like, does anyone, can someone check to see if it doesn't look like the YouTube stream is working. Not sure why. Can someone maybe let me know if they can find this stream on YouTube right now? Thanks. Yeah, it's not. Darn. Okay. Well, I think unfortunately this stream is just gonna miss the YouTube live portion, but I'll upload the recording afterwards. So, if you're watching this from YouTube in the future, I apologize. It's not my intention. Okay, so let's see. We want to pass stability. I'm just checking to see if we're actually still adding the stable field on here, which it looks like we are. So basically, on this class, I'm adding this static field. And that's it. So there's no like getter or setter or anything like that, which may actually be a problem. We might want to add a getter and setter. I'm not sure. Or maybe we need to add a whole companion object. I'm trying to avoid that because I don't want to. Basically, we're going to put this field on every class, and I don't want to create a new class for every class, if that makes sense, which is what adding a companion object would do. And so if I'm going to try and get away with just adding a field, a static field, and then hopefully we can encode that in the metadata in a way that makes sense. But it's a little bit weird because here I'm just adding this property to the class, and there's not really a way to indicate that it's static. So maybe is const. So that's what I'm setting is const to true. I'm not sure if that'll be like good enough. We'll see. Not sure what this has constant thing is for. Did it finish building? Okay, build failed. Or is it still building? Oh. You know, one of the problems is I think because basically this is now happening for all of this transform is now being run on like all of Compose, which if it has a problem, then I've kind of run myself into this chicken egg situation where I can't compile a compiler without a compiled version of the Compose runtime, but I can't compile the Compose runtime without version of the compiler. So I think what I might do first is build canceled. That's deep compiling, yeah. I'm just gonna I don't know, disable this for the moment. Well, actually, here, this is probably the better place to do it. So first what I'm going to do is I'm going to remove that, which is the Serializer plugin. And everything else I think is fine. I don't think it's going to do anything wrong here. Yeah. Okay. Let's try that. And maybe I'll just try running it again. Not sure. Andre says you'll probably need to replicate the descriptor structure. What do you mean exactly? You mean like for? You mean what I generate will need to look something like that? Where my build stop? I don't know what's happening right now. Let me Gradle sync. I'm not sure if I'm in a bad state right now, maybe. So Andre says, as far as I know, IR is created and recreated from descriptors and other modules. So you'll need to replicate whatever the structure is, maybe with the companions. Yeah, maybe. I guess I'm wondering if I can get away with, like, because the problem is I don't want to like double the number of classes that get generated. So if a static final int is going to require generating a bunch more classes, I'm not sure that I want to do that. Like, one of the important things, we want to make sure that R8 can inline it, but yeah, the proto is just metadata, but like, if I guess all these things kind of tie together. So if I had a proto that said I had a companion object with a constant integer, I feel like that I should generate the IR to do that. And then I think that still ends up generating, even if the static final int ends up as like a JVM static, the companion class still exists because it like needs to in the type system. And so we're still generating 2 class files for that one class, and I want to try to avoid that. And then the external stubs will also get generated, I think, which is probably pretty cheap, but it's more that I want to avoid the class file. That's the biggest thing, I think. But we'll see. I don't know. I mean, the proto like metadata format might like prevent me from actually describing something like this. So I'm not sure. I'm not sure what this is const will end up as. Yeah, at least my like very brute force testing of this was that, like, if I have a class with a you know, with like a const int on it, or if I have a const int on like a companion, then the bytecode that gets generated still has a companion class, but the const int will end up as a static on the original class. And then I guess that you know, they just rely on the companion getting stripped away or not loaded. I'm not really sure, but I wasn't happy with my like rudimentary, just, you know, smoke testing of what bytecode gets produced. Yeah, that's true. If I don't call the companion, then if I don't generate code that uses the companion and the companion doesn't exist, then things will probably just work. But it starts to feel a little bit weird. Like, I don't know how to generate IR that has a companion without also generating the companion object. So I don't know. Okay, is this gonna like finish running at some point? Gradle sync finished, okay. So now let's try debugging this. I'm not sure why this debug button isn't available for me. This is not good. I'm in like a weird state. Cannot resolve the project. Okay. Might need to do something real quick. So I'm going to just chatting mode for a second. I think I need to restart my studio instance. While we're waiting, if anyone has any questions, be happy to answer them. What is on your mind, Internet? Is there a recommended way to do HTTP calls with Compose? No, not really. I mean, I would just use whatever networking library you would use otherwise. Now, if you want to like make a network call from inside of a composable, you know, you would want to make sure that that call had the right life cycles and stuff like that. And one potential way that you would do that is like one potential way you do that is using like launch and composition or something similar. But you know, you might also then want to like write your own kind of utility composable or something to do that. But for like high scalability and stuff like that, and for like a robust application where you're essentially making a network request and you want to ensure that you're able to survive as users are navigating across screens, and like the composable may enter and exit the hierarchy and things like that, then doing that network call from like say a view model or something would probably be more advised. But there's so kind of neat, but there's like a new hold on one second. There's a new API that's coming out that would look something like this. You know, foo equals PurdueState, and you'd pass it an initial value, and then in here, this is basically a suspend function, and you can set a value in here, like, so for instance, you know, SkyColor, like in your like counter example, right? You know, you could do like a forever counter here, that just, said delay 1000, set value I, and did this. So like this would be this would be kind of a weird example, right? But we can't see line 1 in full. Is it can you not see what's happening right now in the composable fun example? But so what this API would let you do is, essentially set a state value over time inside of a suspend context, and then that ends up just getting bound directly to a state object inside the composable. And so if you had a suspend based like networking library, then this would be like a really obvious, clean, simple way to do that. So that's just one example. Okay, let me. All right, it looks like I think I might have fixed these studio issues. Sorry about that. I've just been bouncing around different branches and things, and I think I got studio into an unhappy state. Yeah, so I mean, so PurdueState uses launching composition under the hood, which, by the way, like launching composition, I wanted us to name launching composition because I wanted it to be an ugly name. Like I wanted it to be this like long name that people typed out because it's meant to be like a primitive. And so like the idea is that people should build useful, like reusable utilities on top of launching composition, and that we would end up seeing, what the world created on top of this, and then taking that as feedback and then producing solid higher level APIs that used that. And so PurdueState is kind of one of those higher level APIs that's built on top of launching composition. Okay. Yeah, I mean it was kind of named intentionally for you to not think that it's like this, beautiful, clean, elegant name. Like it's screaming for you to put it into a reusable utility function that does something higher level and cleaner. So that was the idea. Whether or not it's happened or not is a different question. Yeah, goal achieved. Sorry, Master Phillip, I see that you asked, did you come to the end? No, we're sort of just getting started, but I was having some trouble getting my IDE in a good state and just getting stuff built and stuff like that. So I had to go into like the just chatting mode for a minute. But I think we'll be good now. Oh man, sorry. I should remember to do at least one build before starting a stream. No, I haven't tried that. We can play around with that though real quick. Let's see. While we're waiting for the build. Set nav bar. Let's see. Yeah, I mean, so there's this set navigation bar color on the window. So I think let's see. If we had our app here, what I kind of want is like let's just say color equals color dot black or something like that. What we kind of want to do is, let's say we had this nav bar composable. So in here we could just say, okay, whenever color changes, well, we need to get the current window, which context ambient current. So I'm not sure. I think we might have like an activity ambient. Not sure though, but if we did, then we could just say dot window dot what is it? Set navigation bar color. So doing something like this would mostly just work. It gets a little bit weird though when you start having like multiple people call this. And so you would maybe want to change the structure of this composable to handle this more elegantly. But even so, I mean, doing something like this is like, if you were doing something like this and just had this kind of infrastructure lying around in your app, and like you weren't publishing it as like some third-party library or something, like this would be a pretty reasonable way to get you started. And I mean, you could even you could basically have this use like a global basically. So my nav bar color by mutable state of color dot black, or like whatever the default color was. And then like in here, you could just say what would you want to say? You know, so if color was that, and then you could have it. I guess what I'm trying to do is eliminate some of the multiple sources of truth. Like if you could treat this just as the source of truth here. So one thing maybe you could do is like you could say like maybe in your main app, so let's say this is like your app here. So I want to spend a little bit more time thinking about like what a good pattern for this would be. I mean, doing this like out of the gate will work, but you still run into like some weird issues if you end up setting it, you know, in multiple places, different colors. Then you end up like fighting with the other instances of it, and so it's not really a true API in that like by calling this, you're not doing something local, you're doing something more global. And I don't know, I mean, we could think about maybe what a better API for that would be. Like I wouldn't be happy publishing this as like a first class API, but just sort of like a quick and dirty approach, you know, it's pretty reasonable, I guess. Hey Dev Souza, good to see you. We're waiting for my build to complete and hacking around with navigation bar while I do that. Hey Joe NRV. Yeah, I mean it is a bit hacky, so I'll think about a less hacky solution. There's definitely an asterisk on that, but yeah. Okay, so here we are. We're determining the stability of any, which we don't really care about any right now, so I'm just gonna pass right over that. Okay, so here we are. We're looking at deserialized class foo. So we're in that second module, and we're looking at a deserialized view of the first module. And what I want to do, so we've got declarations here. So let's see what shows up here. Yeah. Oh, but we haven't turned our Serializer plugin on, so we wouldn't expect anything different to show up here. Which it doesn't look like. There's no field here or anything like that. So these are all just the any overrides. Okay, so I'm gonna go ahead and hit stop, and then now I'm gonna turn back on our Serializer plugin and try running the same code again. And so now I think it won't end up recompiling the whole world, because our because our great old build dependencies aren't smart enough to know that they probably should. But in this case, we're relying on the fact that our build system isn't smart enough to figure that out. Oh, it's weird that it's showing me an alternative source for myself. I don't want that. All right. Yeah, it looks like the source is coming from, like, I don't know, some build or something that I must have picked up on. SkyColor asks, can you talk a little about Snapshot and how it's related to state while we wait? Yeah, I'm curious, like, if you have a more specific question. So the Snapshot architecture is like, it's something I'm familiar with, but I didn't write it, so I don't have like sort of firsthand knowledge of everything. I have a pretty good idea of things. That's about it. But if you go to if you go to state, well, okay, so we've been interrupted, but I'll go back to that in a minute. Okay, so it doesn't look like our stable declaration is there, but let me see if so. Inside here, should be able to type in some of this. You guys can see this. So we've got an IR class. Let me see, does the companion object show up? No, it doesn't. So so there's no companion object, but let's take a look at the descriptor. Oh, wait, okay, so this isn't foo yet. This is any. All right. Okay, so now we're at foo. And interesting. Okay, so there's a lot more declarations here, which is good. So, okay, cool. So here we see public const final val stable with an unknown type. So we must be doing something wrong there. And it has a backing field. And it's not described as static. Let me see. Let's see what the backing field is. So, well, actually, what else is here? Oh, there's multiple properties. That's weird. I wonder why that happened. So it looks like there's like 4 versions of this stable that showed up. Which is interesting. I mean, I guess we might be required to like check to see if we've already called this plugin. We should set a breakpoint here and see if we're calling it for the same class descriptor multiple times. I wasn't expecting that. Let's find out if there are any differences. Oh, and then these, so they all have the same instance. That's also weird. It's, see how the memory address is the same? So it's like it's on here like 4 times, but it's the same property. Okay, weird. Let's do this. So declarations dot okay, and then I kind of want to see what the backing field looks like. So that's a lazy field. So the backing field says is static false, which isn't quite what we want. I'm not sure why the unknown type is showing up here. The way type happens is a little bit weird. You know, I'm not super familiar with the like serialization stuff. Basically, so in here you when I set the return type, you know, the return type is basically like an int. I don't know, but I guess there's this type thing. But I'm not sure if that's the right thing to use when it's like a primitive type, like an int. So I don't know. We'll have to play around with that. And then, so I mean, it looks like it set the name properly. I wonder, is there, what are the different member kinds here? So I wonder if at some point we should use synthesized. If we do that, then I think the front end won't expose it to, like, you know, autocomplete and stuff like that, which is something that we don't want. Right? I mean, we want it to not show up. So I think that using synthesized here might make sense. I'm not really sure what has constant refers to. And then the whole has constant thing. Oh. Is this looks, oh, Boolean after is late in it. Okay. Like, I'm not sure if this is documented somewhere, but I don't know. I don't really know what that refers to, like has constant. Yeah, so I want to find out if this is getting called multiple times at a minimum, but it seems like this return type thing is kind of wrong. So I do wonder if there's like, go ahead and stop it. Like I want to figure out how to get the right return type. So like maybe there's some way of getting it from a primitive type. So if we have a type builder, then we can add an argument, but we aren't going to have any arguments. So I don't think that that's what we want. Is that the class name? Maybe. I'm not sure if that's what we want either. Default instance for type. I'm not sure. Like it seems like if we go into descriptor serializer, it creates some of these. From their source code, you could try class name. Do they use class name? Like even for primitives? Like they have type here. So I mean it seems like they've got an existing type table, but then they just call type on that from the table. Okay, so that just gets us the type ID. So this is really what we want here. And so it won't be an error type, and it's not a flexible type. So we'll end up here, last descriptor. Seems like we'll end up here. Hey, Danny. Can I like set the return type ID or something like that? Let's see. Okay, so I can set the return type ID. I'm thinking that maybe what I do here instead is I say basically what I did here. Type ID, and then pass in the int type. Yeah, but I'm not sure that table is going to be predefined if it hasn't encountered the type yet. But I'm not sure. I don't know. So maybe let's give this a shot, see if that works. And then let's also use synthesized here, because I kind of want to see if we can still see it. We use that, and then we'll set a breakpoint here, so that we can see how many times it's called. So while that builds, someone asked about state and snapshot and how they relate to one another. So I'll kind of go into that a little bit still. So if you look at, well, state's deprecated, but if you look at mutable state of, mutable state of is really just it's a more narrowly defined version of like the snapshot mutable state constructor, because snapshot mutable state is a private class. So this is basically just saying, you know, give me an instance of your state implementation, which in our case, as an implementation detail, we're using snapshot mutable state. And so mutable state, it's going to implement this, which is like the public interface, but it also implements state object, which is a snapshot specific thing, which is going to have some of these things. And you know, basically, whenever you read a snapshot state object, all right. To be continued. Okay, so here we're calling it on foo. And I'm kind of curious what it gets called with here. Type.isError. What? That's weird. I wonder if there's like a source code mismatch here. Yeah. Okay. So some of these line numbers aren't matching up properly. Where's this getting this from? This is 27.2. That is weird. I'm not sure. I don't know what's going on there, but we might be able to get some notion of what's happening. Just calling type. So I wonder if we can set a breakpoint here, if we'll hit it. Set a few. See, these aren't catching, but this one is. All right, let's see if we do that. Okay, so we are going into the fill from possibly inner type, which uses the int classifier. Makes sense. Okay. And then we're calling this again with the same descriptor. Is it recursive or after class? No. So what does this do? So we're generating the metadata in here. So it's weird. I wonder if it's running over the class multiple times. So this is descriptor-based class code gen. Is there any reason we'd be hitting the class multiple times? I don't think so. Okay. Version requirements. Okay. So the class descriptor is 1116. And the IR class is 1619. So here it's the same descriptor, same IR class, but we did hit that code 4 times, so that checks out. Okay. I'm pretty confused. Okay. Gonna try running that again. Like I wonder if it's an expected contract that plugin gets called multiple times for the same descriptor, or if we're doing something wrong that's causing it to get called multiple times. I'm not really sure. This seems to run a lot slower whenever I've got OBS open, I guess. CPU's hurting. All right. So here we are. Generate files, class code. Okay, so let's see how many. So we've we've just got one declaration in the IR file, which makes sense. Then we hit or create a class cogen for each one. Then we hit generate. So far makes sense. So this is our class, and so our descriptor is 119.28, and we've got 111.13 for the class. Okay. So we get called with 119.28, which makes sense. And then all that, fine. Okay, so we're getting called again. So again, it's 119.28 and 111.13. All right. I don't really understand why, but I guess it seems like this plugin runs quite a bit. All right. Like it's calling after class directly here, but I don't see that call. Extension maybe does it. If I search for after class here, it doesn't even show up. So I'm not sure where this call is even coming from. But for whatever reason, this gets called multiple times. So I suppose we want to check the proto and see if it I guess we can check to see if it has one of these in it. I'm not entirely sure how to do that. Let's find out. So I guess you all don't see the autocomplete here, but so there's an add property method, but then there's also a set property method. So we should be able to get the property. So let's try that. So proto.get property. That wants an index. I'm not sure. There's a list of properties. So like, is there, maybe there's a find property method? I don't know. Okay, so there's a property list. I can say if any of the properties have this name, I guess. So I guess we should do that. So we should say val name equals this, and if any of the properties have that name, then we just return. Let's see if that works. This is kind of, I mean, it feels kind of silly that we have to do this, but you know, I guess it is what it is. So, so I'll try that. So now, in the meantime, let's go back to our mutable state. So, so a state object has a state record, right? We call that first state record, and so that is just a, like, if you can imagine every state object that exists like abstractly, what happens is we end up keeping copies of it around, and we call those records. And those records, they're not technically immutable, but you can kind of think of them as immutable. Like they're their own kind of snapshot, like, version of that state object in any given snapshot. And so what the first one points to is kind of just like the most recent one, and it's not necessarily the right one. So if for instance a different thread is like mutating or using this state object, it might have created a newer snapshot or like record of that state object. And so you don't necessarily want to return the value of that one, but so what we do is we call readable, like with this passed in. And what this does is, this is a function that basically says, given the current snapshot that I'm in, which state record should I be looking at? And then whatever it returns, we give you the value of that. And in addition to giving to saying, okay, give me the version of give me the state record that I should be looking at, it's also an opportunity for us to say, hey, you looked at this state record, so now you're kind of like subscribed to it, like you needed that information for some reason. But if you look, what this does, basically this passes in the current snapshot. And so the current snapshot is kind of the snapshot you're in when you call .value. If you increase a counter and a timer, then you get two snapshots, one current on main thread and one old in timer. Well, so we have the concept of a global snapshot, and so that's sort of like the root of all snapshots, if you will. And so if you the global snapshot, if you just mutate a state object just kind of anywhere, then like it's gonna use the global snapshot. But if you mutate the snapshot from inside or if you mutate the state object from inside a snapshot, then it's gonna use the current one. And composition happens inside of a snapshot. And so I'll need to look at exactly what your code was again. Maybe we can look at your code if we've got some time here, but let's go back to this for a second. So we are Okay. So we're adding the property this first time, and then the second time let's see if we missed the property or not. Yeah, okay. So now we're not adding it multiple times, which is good. That seems to be working. So now we don't want, whoops, not this. So we don't want any. We don't care about any. What happened? I don't get it. Did it fail? Oh, so this happened? This should have caught it. Oh, I see. So this is actually causing foo to fail. So I really need to pause there, because this is not. So, I mean, really, we should. I'm just gonna get rid of this. This is pointless. So I think now we want to check that out. Okay, so SkyColor asks, if you increase a counter and a timer, then you get 2 snapshots, one current on the main thread and the old one in the timer. So if you create a timer, which is going to run on a new thread, then and that thread's not in a snapshot, then it's going to write to the global snapshot. And I would expect that a composable that reads that is still going to do the right thing. Let me pull up the code from your tweet. We'll see if we can look at it. Can't find your tweet here. Oh, here we go. Okay. So let me kind of write what you're doing here. Oh, all right. So we are now looking at any, which we don't care about. Now we're looking at foo. Okay. So now, so it looks like calling declaration.declarations ends up causing an out of bounds exception, which might actually want to understand that more. So it looks like basically the IR and the metadata aren't matching up or something. Maybe like what's happening is the descriptor, I think, is saying, hey, I have a property called stable, and then when we try to generate the stub for that stable property, something is failing. And it looks like it's maybe related. Yeah, so it's related to this, I guess. it has a return type ID, then it looks up the type table from the return type ID, which I guess that's not there. The type ID is essentially an array index, and it's not populating, or it's not correct for some reason. So maybe we should basically check this out and so load property. But yeah, the return type isn't correct. So we're doing something wrong there. That's where it's failing. Okay, well let's go ahead and see what the actual descriptor says is the property. We've got, so the interesting thing is, so the declaration descriptor has a static scope and it's empty, which is probably not what we want. So we ended up kind of adding this member field when really we wanted it to be like a static field. So descriptor dot member scope get contributed descriptors. Let's see what that does. Okay, so that also failed. And for the same reason. So basically our return type here is wrong. And it's causing these failures. So let's restart this, and then we've got the breakpoints set here. Oh, but then I wanted to say basically what I had before. Okay. So we'll set a breakpoint here, but the other breakpoint should get set when we end up calling this. So let's try that. Okay, so SkyColor asks, who has priority, global or local snapshot? So if you're in a snapshot, then you'll see what the snapshot has. But like you can think of a snapshot as like a Git branch, and so the global snapshot's sort of like, you know, like master or main or whatever. And so when you create a snapshot, which composition should do, it'll sort of create a branch off of like current master. And when you commit a snapshot, it'll sort of like merge that back into the global snapshot. If that makes sense. So let's just write up real quick like what you were doing so we can play around with it. So you've got a counter timer, set a mutable state of int, and say val counter equals mutable state of 0. and then you're getting a lifecycle owner, and then you launch in composition. So this is like the weird thing you're doing, I think. When started, timer, schedule at fixed rate, and then counter.value plus plus. Date 1000. Okay. And then what you're doing is you're saying, let me use this and say val counter equals counter timer, text count value. Okay, so I mean there's a few things here. Like one right away. So I think part of the problem here is that you're creating a new mutable state every time, and so this mutable state isn't necessarily tracking the old mutable state, and so each time you're going to reinitialize it to 0, and then start reading that new mutable state. And so it could be that just adding a remember here is all you need, and that the rest of this will kind of work as you expected. So I'm not sure exactly what it is that you're wanting to do, but like one, like kind of like I said earlier, like something like this might be an easier way to accomplish this. But I mean, if you're already using suspend functions, then you might just do something like this, and then that value plus plus. Because one of the things in here is, so timer I think is going to end up running on some thread somewhere that won't necessarily, I don't know what timer does exactly, but it may not be in the right snapshot, whereas this suspend function is, and so like doing this might just kind of give you what you want. And then you don't need the lifecycle owner, and then you can return counter here. And realistically, I would, so I mean, just some additional kind of code feedback here. Like, I would just return state if the idea is that this timer is handling the mutation of that thing, and so then you're just doing this. And then this basically is what the PurdueState example is doing. So like PurdueState is an API that does a little more than just remembers a state object with an initial value, and then calls launching composition, and then lets you set that value like over a suspend function, and then returns that state object. So that's basically what this is doing. So this is basically that. But let me know if this sort of accomplishes your goals or not. But my guess is that the issue was just that you had forgotten remember here, and then we're kind of running into a bunch of other problems related to that. Okay, so here we are. We're this is like for any, I think, so I don't think this is actually what we need. Where are we? Compute descriptors, version checker, check. Oh, okay, I see. So yeah, so we can skip that, and then this is so we're basically calling this getter like because of other side effectful code that I'm running in our lowerings. So we can skip that. Skip that. Let me actually just go and let me just set a different breakpoint so that I know when we're getting there. So basically we're not going to hit any exception until here, so let's just continue until we get there. And I'll just turn this off for a moment. Okay, so we're right there. So we'll turn these breakpoints back on. And I think this is going to be for any. Yeah, so this one should work fine. So we'll continue. And then this is the one that's going to break. So let's go in there. All right. So now we've got our type table, which holds 6 types. I don't know what these types are. Which is, you know, kind of scary, I guess. I'm not really sure. I guess we could call the local type deserializer. Yeah. So like, let's just okay. So our property has a return type and a return type ID. So I guess has return type is going to return false. Is that right? Yeah, so has return type returns false. And has return type ID returns true. But that's a little bit surprising to me because the return type here is non-null. So that's weird. So what's the type table? Let's see, is this type in the type table? So 9822, no. Oh, but it's the same as the receiver type. So that seems wrong. All right, let's see what shows up here. Like if we do, I want that. So inside of load property, if I say local type deserializer, and then do c.type table do like 0, what happens? C dot. Okay, so any is what's in the first index. Here's what I'll do. C.type table. Just type table, not an array. Types dot map. This is a frustrating experience here. So that should give us a list, and then we're going to map it to local.type-to-serializer type, and we're going to pass in it. So let's see what that produces. All right. So here's our list of types in our type table. So any int, t, function, iterator, and unit. Which actually, I mean, so that checks out. Because, so index 1 is what we want, and that's what it was set to. So return type ID is 1. So I wonder if this one will actually succeed. Okay, so let's just do this. Let's go up and then back in. So this should end up returning us the int type. Okay. Okay, so this is the problem, I think, is that the receiver type gets checked. Yeah, I think that's the issue. So the receiver type, which is 9822. So what is this function? I think we just want no receiver type, right? So maybe we need to set that explicitly. Okay. So this is, I think, what's going to blow up. What has receiver type here? False. False. Oh, no, this isn't what blows up. So it should go into else here, I think. Okay, which that's what we expect. So that returned null. So then all of this is going to return null, which means that we should end up in the set type function. Okay, which is where I just set the breakpoint. And here our out type is int, so that looks right. All right, go up. That's interesting. So we haven't blown up yet, and I thought we were going to. Like, I wonder. Ground level. Crazy. Where are we right now? I feel like we're on the wrong thread. We should be. Oh man, what am I even doing? I don't. All right, let's just continue. So. Weird. Okay. I'm just gonna undo this and this. Like, I don't know if it lost my place at some point or what, but okay, and it actually printed the declarations. So that call worked. It didn't throw an exception, which is good. So now I kind of want to go back there and figure out what this looks like. Oh man. So SkyColor, let me know if that that explanation I gave you for the state and the counter and stuff, if that made sense to you. If it didn't, we can talk about it more. Oh, the chat stopped working? That's weird. What were you saying? All right, I can read the chats now at least. Oh no. Sorry. Okay. Oh, that's any. Oh. So I guess it did still error out. So SkyColor says, I was wondering if there was like a high level function and plan like that PurdueState or ApplyState or setState that would do the snapshot merging. So the dev does not have to worry about it. Yes. So it really depends on what you want to do, because I mean, right now a lot of that does happen automatically. Like I think, I suspect, I don't know for sure, but I think that your example, like, it wasn't not seeing the original state object. It's just that every time it recomposed, it was now looking at a new state object, which didn't have the changes from the previous one. And so you just kept changing the original state object, but the composable wasn't subscribed to it anymore. And so I think that was the problem. But now if you remember it and then you continue to mutate the same state object, then even if this is in a timer, it should still work, as far as I understand. So your composable will now subscribe to the one and only count object, which is going to be the first one that you create. And all of the snapshot merging and all that stuff, all of that is going to work correctly. So I think even without launching composition, this should still like work in the sense that like, at least how you're thinking of it. So like if I did something like this, and then, we tried like your original thing. So like, I had lifecycle owner here, and then I did lifecycle owner when started, and then timer, whatever it is, like this should still work in the state sense. So this should still produce a timer, which will mutate counter every second or whatever you set it to, and everything will get subscribed appropriately and all that. Now what you need to do is you need to like turn the timer off when unsubscribe here, or else it's like a memory leak, like this lifecycle owner needs to figure that out or whatever. But it should still work. The key is that the subscriptions are based on the state instance, and so if you're creating a new instance each time, the subscribe semantics aren't going to work at all, and this should work just fine. Now the difference between this and the launching composition version is that this one, so this one is going to end up mutating in the global snapshot, whereas this one will end up mutating in a nested mutable snapshot related to the composition. And so this one is a little bit better in that if a composition happens and never succeeds, or if this composition is part of a greater snapshot and whatever, then these mutations won't be seen until that larger snapshot commits. Whereas this one, it's just going to be seen kind of regardless because it's mutating the global snapshot. So I don't think that using launching composition here was the trick or anything. The trick was using remember and focusing on a single state object. At least that's I'm pretty sure that's what was going on and why it wasn't working for you. But let me know if that doesn't end up working that way. So that's annoying. Ended up enter error. Gosh, these builds are so slow. I'm not sure why. They seem to be much faster for me when I'm not streaming. All right. This is any we don't care about. And this is foo. All right. So I guess if I call declarations here, this is going to cause an out of bounds exception. What we saw. So where is the okay, so here's stability of functions and properties. Okay. It seems like it's still failing here, but I don't understand why, or I don't understand how it's different from when we step into it. So here, let's set a conditional breakpoint here. Index greater than types at size. All right, that. I wonder if we can rerun. Tapco Wild asks, do you know why Java developers require 2 displays, 1 portrait and 1 landscape? Is this like a knock-knock joke? I'm not sure. So no, I don't know. Are you about to tell me why? Is it something related to debugging? Yeah, so SkyColor, if you use onCommit, this onCommit's gonna run every time, and you're calling counter timer every time it gets subscribed. So you need to like, you need to basically tell it that like don't run onCommit again if counter hasn't changed. So if you do it like this, then it should do it once every second, like you expect. Okay. Interesting. All right. Well, I guess that breakpoint didn't work, but yes, that's right. Uncommit is similar to use effect from React. Gosh. All right. So I wonder, I'm not sure what the right thing to do here is, but we've got this like serializer. I don't know why this file is like not searchable for some reason. Okay. I wonder, I mean, so if let's just like not say it's not constant. Doesn't have a getter. Let's move that back to declared. I don't think we want to set the receiver type. All right, let's just see what that looks like. Oh, shoot. All right, so it's 3:10 right now. Actually, I have some meetings I need to go to. So I'm gonna have to cut the stream at this point. So thanks everyone for tuning in. We'll be continuing this work on Friday, and hopefully I'll get some time to work on it a little bit in between now and then also, and so maybe we'll be able to stop fighting with this little subsystem here. But anyway, appreciate everyone who tuned in, and you know, let me know if you found this useful or anything. And I will see you all on Friday. Cheers.